Okay, so we're picking back up. We had just completed the Boolean logic, the conditional ifs, a moment ago. And the question I left you with was, it's actually just this one right here, right? So what do we do if we want to execute, or if we want to do something a little different and we want to execute the same code over and over again, right? So maybe, for example, we have a whole list of patients, either from our clinic for the day or from our data warehouse, for the whole year, or whatever the case may be. And we want to check each patient for something specific. And each time we see it, we want to do something on that patient, right? We want to execute some code for that patient. And that would be the same thing happening over and over and over again for as many patients as we have, right? So currently with the tools that we've been given, we would have to do something like this. And it's probably not very pretty, but we'd have to declare a variable, right? We're going to say, here's my patient 1, name and gender, my patient 2, name and gender, patient 3's name and gender. And then I'd have to go check each of those things, right? I'm going to go say if patient 1's gender is female, do this. If this patient 2's gender is female, do this. If the patient 3's gender is female, do this. I could do something like that. Or using our fancy logic. Well, hang on, before I fancy it up, just notice that there's a lot of replication here, right? I'm saying if patient 1's gender is female, do the exact same thing, right? You can see how I'm duplicating code, right? This is identical, except that I'm just checking a different patient, right? Patient 1, patient 2, patient 3. But what I'm doing is identical, right? I'm saying if you're female, then whatever. Here's what I want to do. We could fancy this up slightly. Right, we could do this. And when I say fancy it up, I'm talking about being more efficient, getting rid of code. Right, so now I can put it all just in one. So my code's not being duplicated, but my checks are, right? So what I do if it's a female is only happening once, but my conditions are being repeated. And you can see how this wouldn't scale very well at all, right? Because I'd have to go set up all these different variables for all these patients, and then do all these checks and rewrite it each time I have patients, right? So in this case, what would we do if we had 900 patients? I'd have to go create 900 variables and then go do this check 900 times. And you can see that's sort of problematic, right? That's where we're at here. So we're duplicating things, we're duplicating our work, we're duplicating our logic. It doesn't scale very well. That's what we're talking about here. It doesn't make a lot of sense, right? We can improve it, right? We can do lists, right? So instead of using single variables like we're doing here, we can do a little bit smarter way of doing it and create these lists. In this case, this is a list of lists because we have multiple values, right? So now instead of having those 6 variables, we have one variable called patients. We stuff in the exact same data we had above, right? The patient's name and the gender, patient's name and a gender. So we have a list of lists, right? So we've improved things a little bit. So now we can just go reference this. So using the same sort of thing. So the whole idea here is we start with a really bad example, and I'm going to be going through slightly how to improve it using these new tools that we're about to talk about, right? And how it's falling short with the tools that we do have. So I can rewrite this to be a little bit better, just like we did above, right? So we can say, go to the patients array, look for the first patient in there. Because remember, all of our counting starts at 0. That's what we're talking about here in 255. Anytime we have a list or an array or a collection of things, our counting always starts at 0. So 0 is the first item in the list. So I'm saying go to the patients, right here, go to the patients list. And in square brackets, it's the index of how we access it. I'm saying go to the first item. So that would be this. This is the first item. And then the second square bracket is saying within that list, go to the second item in that list, right? So I'm saying, all right, we got the first patient, it's Chad, and then go to the second item in that list, which will be the gender right here, right? It'll be the M. And then likewise, when I switch down here, I'm going to the second patient, second item, third patient, second item. And so I'm going to show you here, just like we did up above, we can also, I think we did ORs above, right? Yeah, we did ORs. There we go. So we could get rid of that stuff. You can see we still have an issue though, right? So even though we're down to a single variable, which is favorable, right? We got rid of all of that stuff right here, all of that stuff. We're able to collapse it down to a bit more of a generic container, this sort of thing. But we're still duplicating all of this stuff right here, right? We're having to do a check for everybody. And this is sort of the idea here. I'm showing you that with our current tools we have, this isn't going to be a real easy problem to solve, right? Again, what do we do if we have 900 patients? The patient's variable will be fine, but this if condition is not going to be fine. Okay. Yeah. So here we're taking the list, right? We talked about lists earlier in data types. But we have a list and we're grabbing items specifically by index. And we may not have seen that before. I don't know if we've talked about that specifically. But again, that's what the square brackets are for. And we're saying go grab 0, which is the first thing in the list. And then 1 is the second thing in the list. And then 2 is the third thing in the list. And I wanted to point out, this is a common mistake that some people make, is what if we have a bit of code like this? I hit save. It doesn't turn red at all. But it's saying go find the third thing in the list, which means the fourth thing in the list, right? Because we start at 0, so we're the fourth thing in the list. I'm going to run this code or get it down here so we can run it. Actually, I didn't save that code. Hang on. Oh, we had an error in our code even before that. Hang on. So indentation matters. So I had an extra space. I had just a space like that. And you cannot have, in Python, everything has to be left aligned. If you have any spaces, it is going to, just like it's doing right now, it's going to have a little bit of a heart attack on you. So it has to be all the way left aligned. And then I'm just going to tab that over just to make sure everything's aligned. So hit save. There we go. Okay, so we're going to hit F5 on this guy. We're going to skip over this stuff. This was the Boolean stuff. Okay. There we go. So we get down to this line of code, right? I just wanted to point out that this is a mistake that happens a lot with beginning programmers. So what's happening here is we have a list of patients. You can see it's right here, right? We have a 0 spot, a 1 spot, and a 2 spot. But this code, this condition is asking for what's in the third spot. And there is no third spot, right? We got 0, 1, and 2. And so this is an out of range exception right here. Index out of range. So that's saying you're asking for data on that list that simply doesn't exist, right? We only have 3 items. You're asking for the 4th item. It's like, I don't have 4 items. I don't know what to do about that. So it just throws an exception. And this is what it looks like. It's going to be this big red honking thing that's going to stop your whole program. So I wanted to point that out. If you see something like that, that means you're asking for data that it doesn't have, or you're asking it to do something that it can't do. Okay, so if you see that, just know that that's what's going on there. Okay. So this is about as good as we could have gotten it, right? So these 3 lines of code, right? 252, 257, 258. Those are the 3 lines of code that we've boiled it down to get as efficient as we can using the tools and the knowledge that we have currently. But to make this better, to make this truly a scalable sort of thing that we want to do, right? Again, we're trying to read all the data for all the patients at a clinic for a day or something like that, right? Maybe we have 1,200 patients in a day come to some clinic. And we want to do the same piece of logic for all 1,200 patients. And we want to do it conditionally, right? If you're females, do this. If you're male, do that. If you're transgender, do that. Or whatever the case may be. And this is, using what we have now, this is the best we can do. So we need to introduce a new concept, a new tool for us. And this is where loops come in. There's a few different flavors of loops, and that's what I called it right there, a few different flavors. We'll go through them all, but we're going to start with the for loop. For loop's the most easy to understand loop we got. So we're going to start with that. So that's on line 272 right here. And so what this is saying, you can see we have the same sort of thing, right? We're saying if our patient, the first thing in our patient, if the gender of our patient, right? So the second item, and that's on this thing right here, 252. If the second item, right, of that patient, which is gender, is equal to F for female, then go do something, right? So this is pretty much all the same of what we had before. The difference is we have this top line, 272, and this is our for loop. And so we're going to go say, and we have this keyword in that goes apart with the for loop. And so we're saying, we're going to go find, go to this list of patients, and in that list of patients, pull out each item that you come into, right? Read the next item in that list and pull out that next item and store it into this variable. I called it patient in this case. I could call it anything. It's arbitrary. I just want you to know it's arbitrary. My wife saw my labeling and thought these were all specific, like saved keywords that meant something to the computer, and they don't mean anything. These are things that I've called it, right? This patients is locked in because we called it that up here. So we're saying go to that memory address, which is a list, and go find each item in it. I'm going to return it back to patient just because that's what the rest of my code is looking for. Okay, and then store it into this variable. And then as you're going to get it, and now I can refer to just this patient, right? So before I was saying go find patient 0, patient 1, patient 2. Now I don't have to do that. It's given me my patients. It's just handing them to me one at a time. And so now that I'm dealing with the patient one at a time instead of as a whole list, I can simplify my code a little bit, right? So I'm saying I got a patient, go find the gender and see what it is, and then do something. So I'm going to put the breakpoint here and execute it. It's probably going to make a little bit more sense if you just see it in action. Okay, so I'm going to hover over this patients. And again, we have 3 items, 0, 1, and 2. That's the whole idea. But now I'm going to hit this F10, and it grabbed the first one. And all it's giving me is a single patient at a time, right? So it's, oh, the first patient's Chad. And the first thing in that is his name. The second thing in that is his gender, right? So that's all I got to do here. I'm going to go say, go to my patient, go to the whatever thing is at index 1. If I don't know, I can copy that and debug evaluate it. That's an M. So I'm saying if it's equal to F, do something, which it's not. It skipped over that, right? Okay, now the loop, you can see the yellow thing jumped back up because this is what loops do for us, right? It brings you back up to have another chance at it, right? So it grabbed Chad, saw or asked, are you a female or a male? The answer was no. It skipped that, so it went back up. It's like, all right, we still got more patients to read, so we're not done yet. Okay, so it says, all right, here's the next patient in line. This is Annika, and she is a female. Okay, now it's like, oh yeah, we got a female patient. Let's do something. Okay, we're going to check their pregnancy before we give them an x-ray. It seems logical to me. But now watch this yellow line, just like I did last time. Oh, it's like, hey, I still got more patients. Don't leave yet. We still got stuff to do here, right? And so now we do it again. And now my patient is Matea. And she's also a female. And it says, all right, check. And you can see it goes back up there. I was like, do we have any more patients? The answer is no. So then it exits that loop and comes out. So I'm hoping by running that execution through here for you, you can kind of see it's just going to keep looping and looping and reading data, handing you little bits of it at a time so you can work with it. And that's what the whole idea of a loop is. Okay. And you can see that we went from having this big gross thing. I kind of collapsed it already, but we had this big, huge, gross thing that wasn't very scalable, and we worked it down to this tiny little precise, good-looking thing. A little bit of code here. Okay, and just like the ifs, the for statements, you just end it in a colon, and then anything that's indented underneath it is what gets executed, right? So likewise, if I had done something like this, it's not going to be too super happy with us. Well, now I'm curious. Okay, yep. Problems right there. So again, it's not telling you exactly what the issue is, but it is that the have to be indented because you can't have an empty for loop. And that's why I was turning red. You can't have any empty things, right? So anytime you have a colon, you have to have something after it. And so there is a special word you can do. I'm not going to introduce it to you, I guess, but you can have empty things if you put in a special reserved word. But if you're going to have an empty loop, there's really no reason to have it in the first point. So we're not going to do that. So this is just telling us we need something under here, right? You need to have something in your loop. You need to have something in your if statement. And whatever those things are, they need to be underneath it and indented. And that's what we're doing. So each time we run a loop over, or an iteration is the proper word, each time we iterate over this list, we're going to do this same bit of logic. And this is obviously a very simple one. You can do very complicated things. Okay. And so this is reusable, right? This same block of code can happen if you have 0 patients, if you have 5 patients, if you have 1 billion patients, right? It's just going to keep looping and looping and looping until there's no more data. It's very simple and straightforward. Okay. So I just want to take this off. I want to show you a couple more examples of loops just to show you what happens. Hopefully it'll help drive it in. Okay, so up here we had 3 patients. Here I'm getting rid of that. I'm emptying it out and saying patients is an empty list, right? So it's shown right here. There's nothing in our list of patients. So what happens when we get to a loop and we have nothing, right? We have no data to loop over. Nothing. It just says, it gets to the for loop, says, oh, I got nothing to do, and it skips over the whole thing, and the whole loop exited. Hopefully that made sense, seeing that yellow thing just sort of jump down. This yellow thing right here, jump down. Right, it tried to read it, there's nothing there, so it just skipped over it. And that's the best we could hope for. Here's a different one, slightly different flavor. We don't have to use just lists, because again, if you remember, strings are also sort of implicitly a list of characters. So if I give it a name, Chad Hodge, and I say go find for each character in that name, Chad Hodge, do something. So it's going to go grab one character at a time and just print it out. So you can see the yellow thing, right? It's jumping up and down, grabbing the next letter. And then I'm just printing them out here. So you can see down here at the bottom what's printing out. It's grabbing each letter at a time, printing them out. Then finally at some point it's going to run out of letters like it is now. And then that whole loop exits. Hopefully that makes sense. And again, this word character is completely arbitrary. It could have been just like this. You want to give it something that's going to make sense and be obvious, but is also not going to be a reserved word, right? You can't use reserved words. Like I can't call my variables for, because it's that means something already. For, right? So you got to have a name that makes sense, but is also not a reserved word in Python. And other than that, there's really no rules. You just want it to be something that's meaningful. Okay. Okay. So the for loops are pretty, I don't know, they're pretty simple. I don't want to say dumb. They do what they're supposed to do, but there are lots of cases, because all the for loop does is it's going to read everything in your list. It's going to go say, if you got 1 million patients, I'm going to read 1 million patients, and I'm not going to stop until I hit all your patients, right? And there's lots of cases where that may not be what you want to do, or that may be wildly inefficient, right? And this happens all the time. Examples, right? So I work at Intermountain. We have an EDW, which is an enterprise data warehouse. And in there, there's something like 12 million patients, distinct patients that have ever come to Intermountain Healthcare. And I want to go through, and again, this happens more than you would think. I want to go through and find, say we want to do some comparative effectiveness study. We want to go find patients who meet like all this criteria, right? They have to be a certain age, they have to have certain diagnoses, they have to be seen in certain clinics or within a certain date range, have certain lab values or whatever, right? And we just need to go get 100 patients that meet this criteria, right? Just 100 patients, and out of 12 million. And so if we were to put that in, when we do put that in a for loop, I should say, because it's something we would do, we throw that in a loop of some sort, it's going to read all 12 million patients, right? But we just want to grab when we have 100 patients and stop. And once we do that, we could have, maybe we've only read through 1,000 patients, right? Maybe we started reading through 1,000 and we already met all of our criteria. Well, that loop is still going to go, 11.99 million more times to read all 12 million patients. That's wildly inefficient, not only just for time on the CPU, but also on memory. Because each time we're doing this loop, we're working with memory and incrementing or checking things. We're going to be eating up a lot of memory, and it's just super inefficient. And so in order to do that, once we have met a certain condition, we can exit a loop whenever we want. And to do that, we have this keyword break. Okay, so anytime in a loop that sees the keyword break, what's going to happen is that loop is just going to stop where it's at and exit. because it's going to assume that you've already done everything you need to do. So you're just telling the loop to stop, to break out of that loop. So I gave you the 12 million patient example of Intermountain, but here's a simple, or a different one, I should say, one that I could actually code up and show you. I couldn't code up 12 million patients in here to show you, but I can show you. Let's say patient has 10,000 lab items. So I'm setting a variable called lab items, and it's going to be a list of numbers. I'm using this range function. If you haven't seen the range function before, you probably have not. This is something that comes in Python and helps us build a list of numbers or a list of things. In this case, it's a list of numbers, and we're saying start at the number 1, go to the number 10,000, and increment by 1. So what this is going to do is say all the numbers between 1 and 10,000. Actually, it's between 1 and 9,999. And we're going to increment by 1. So it's going to be 1, 2, 3, 4, 5, all the way up to 9,999. And you can use this to fill in gaps of things, right? Because how long would it take me to write a list of 10,000 items? Really a long time. All right, so this is telling us right here what's happening or what's going to happen. We're going to start at 1, go to 10,000, and step over just one item at a time. Okay, so let's say this patient has 10,000 items in it. That's a lot, right? We probably don't need to go through all 10,000 lab results for this patient. We just need to go until we find a lab result with a high value, right? Or whatever we're looking for. In this case, we're looking for lab results who have a high value, and we're considering a high value to be 250, right? So we're just going to go scan through all the lab results for all the patients, and if we see that they have anything over 250, then we're going to assume that patient has met our criteria, and we're going to sort of break out of that loop. Okay? So here we go. First thing, lab result. The first thing we get is the number 1, just like we'd imagine, right? And is number 1 greater than or equal to 250? Nope. Is 2 greater than or equal to 250? Nope. Is 3? Nope. Nope, 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 nope. I'm not going to go all the way through all 250 of those, but if I hit F5, it will have done that for me. So now we're at 250. It met our condition, right? And now we can say, oh yeah, this patient does have a really high lab result. We're going to do something with it. But now that we've met that condition, we don't need to go read all, 9,750 items, right? Because that is a whole lot more reading that this loop is going to do, right? 9,700 more. We don't need to worry about that. We're like, we've met our condition. Let's just exit out of that loop. And we saved ourselves a ton of processing time and a ton of memory resource usage by having this break statement, right? Because it wouldn't make sense. Why would we keep looping, right? We've already met our condition. There's no reason to keep on going in this case. There would be in other cases. So I'm just showing you that we can introduce the keyword break if we want to stop a loop at any time. And you saw that it did. It stepped right out, and now the yellow thing is right here. Okay, so a different flavor or different way you can use a loop, right? So the 2 examples I've shown you so far of these 4 loops is you give it a list of things, and it's just going to read it from start to stop, right? However many data items are in that collection is how many times it's going to loop, unless you tell it to break. But let's say we want to do something different. Let's say we just want to loop a specific number of times, and it has nothing to do with data, right? Let's just say we want to do something 5 times, or 4 times, or 10 times, or a million times. And we don't care about the data. We just have something we want to do a whole bunch of times. And you can do that. You can, again, using that range function, I'm just saying 5. So it filled in all the rest as defaults. If you don't fill in the first and the last, it sort of defaults those all to 1. So I'm just saying, give me a range of 5, meaning it's going to go from 0 to 4, because we always count zeros. Start with 0, right? So it's going to give us from 0 to 4, which is 5 items, right? So I'm saying, give me a range of 5. So 0 to 4 is 5 items. And then I'm going to say, just give me each number. And so this is how we can do something 5 times, right? So this has nothing to do with a list or of data. I'm just saying do something 5 times. So the first time I get an I of 0, and I'm printing this out to the screen right here. You can see it here. This is the loop iteration 0, 1, 2, 3, 4, and then we're done. The yellow execution control jump down here. Okay, so if you ever want to just do a certain task a certain number of times, you can do something like this. Has nothing to do with the data that we're reading. So I just want to make sure that loops are really versatile. Here's an even more complicated one. But say you have a specific set of patients, and you just want to go maybe like do a random sample, for example, or say you want to go, in this case right here, I'm saying just read half of the patients, right? This could be your way of doing some randomization of, placebo versus whatever, I don't know. But let's say you have, what do we have, 4 patients in this case, and we just want to read half of them. This will be the first half of them. So I'm grabbing, what's the length? Meaning how many items are in my patient's array. So the answer to that's going to be 4. And I'm dividing that by 2. So now my answer is 2. And I'm converting that to an integer. And I'm passing it into my range function. So I'm saying, go find each patient in the patient's array, patient's list. But I only want to do the first 2 of them. So if you watch this, we get the first patient, which is, hold on. Yep, right there and right there. So we're just showing the first 2 items, the first 2 index numbers, which we could use those index numbers to go grab the items out of that patient's table. Okay. A little bit more complicated. Loops can be nested. So here's our lab result data. And again, I'm using the range function. I'm starting at number 1. I'm saying give me 10 results by stepping just one number at a time. So that's what it's showing here. We're going to get 10. So it's going to be 0 through 9 in this case. Okay. So as my wife would say, pause the video, look at this 4 lines of code, 328 to 331, and think about in your mind's eye or logically in your brain, what do you think the output would be from this? This is a nested for loop. So I'm going to pause for a second, and you guys use a second and try to work through this and think about what you think is going to be output. And then let's see what actually gets output and see if you were right. Okay. So having 2 nested loops over 2 different types of data, let's see if you got the answer right. So we're going to go through my list of patients. We have 4, right? Chad, Annika, Matei, and Carrie. I'm going to grab one patient at a time. First one is Chad. I'm going to print out Chad. So here it is. And then now there's another loop. Oh boy, right? So now we have lab results with 10 items. I'm going to go through and loop and grab each one of those one at a time and print them out. So now we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So that loop finished because we read all of that data. And then this outer loop said, hang on, I got more stuff for you to do probably. And then the same thing, it's going to repeat, right? So now it's going to go grab the next patient. This one's Annika. And again, now it's going to go print out all the lab results, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then once that loop's done, it loses control. And then the top loop grabs control again. So it's all right, I got more stuff for you to do. Right, so the whole idea here is just printing a patient and all their lab results. So hopefully that made sense, right? And you can nest these loops. And this is very common. This is probably the most common way to use loops is we nest them because more than likely we're going to have lots of different sort of things we need to iterate over. And this is the best way to do it, right? So for example, this is another common way. You could have like 3 or 4 of these deep, right? Because say we want to loop over all of the patients. And I sort of skipped a level here, right? Because it's what are the lab tests, right? We're going to go have a loop that says all the lab tests. And then under that loop, we're going to have a loop that says all the lab results. So that would be a little bit different. It would say, here's Chad, here's all of his lab tests. So it would be things like hemoglobin A1C, for example, or creatinine or BUN or whatever. And then it would do all the results for those underneath it. So it'd be like 3 layers deep. And it's really common, right? Nesting these loops. It's very, very common in programming. Okay, so just showing you what a nested for loop looks like. Okay, so all the examples I've given you so far, we're dealing with lists, right? That's what this patience is. That's what they are when we use the square brackets, right? These square brackets are saying that these are lists. And we talked about that with the data types, because it's really the easiest one to use and to work with. But I do want to show you that you have other options depending on your need, and as your skills and knowledge progress, you may want to branch out and to use some of these other things But again, lists get the job done and they're the simplest to use. But we do have other things. We have what are called sets. We have dictionaries and we have tuples. And there are actually more than this. I'll briefly mention those in a second, but these are the other three more common ones that people use in programming. So when we use these curly braces, right? So up here we were using the square brackets right here on line 314. Those are square brackets. Down here we have the curly braces. So the exact same thing, just curly braces. Curly braces tells it that this is a set, right? And I'm printing out the type to show you here. This RESS variable is a set. You can see this is what it looks like when you hover over it. Those numbers are just memory addresses. It's saying in memory address block whatever, I've stored a 1. And in this block I've stored a 6. And I've put them all together in a group. That's what a set is showing us. You can see right here it's a set, not a list. So sets are unordered. So sets have a weakness to them, meaning you can't go grab the first item out of the list like we could up here. Trying to find the example of where we did that. Right here, right? So right here we're saying go grab the second item from that list, right? Which was gender in that case right here. You can't do that in sets. Sets don't let you just go grab data out of them. They're sort of organized differently. So you can't do this. I commented it out because if you comment it in, it'll turn red and have issues with it, or it would if I were to stop and save. There we go. So it's going to have an issue saying you can't do that. Sets are not scriptable or subscriptable. So you can't just go grabbing data out of sets. But you can just iterate over them. Let's go run this again. Get rid of that. Okay, so you can iterate over a set just like we did before with lists, right? Just in a simple for loop. It's going to go read all the data out of your thing, which is all that stuff right here on line 337. Okay, so it did that just fine. But that's not really what sets are for. I mean, you can do that. Sets are for doing some higher order mathematical things. This is why some people use them and some people don't. It's up to you. But most commonly, if you've done any work in databases, I mean, sets are made for doing things with set theory, right? Set theory. That's why they're called a set. Similar to how we use databases. If you've done any database work, that's all based off set theory. So you can do things like unions. Take two lists and get the union of them, meaning just merge them all together. You can do the intersection, meaning what things, show me only the things they have in common, or differences. Show me only the things they have that are uncommon between the two of them, right? What are the exceptions? So I've set up 3 different variables here just to give you an example, right? I got facility IDs, just some numbers, facility names. Again, I work at Intermountain, so these are some examples. 5 different facilities. And then these are some locations where we have NICUs. These are not inclusive. These are just some examples. Hang on one sec. Okay. And so then here's an example, right? So I'm saying go grab my facility IDs, which are all these numbers. I'm going to union them. And then in a parenthesis, I'm going to pass it what I want to union to it. That's these strings, right? Those facility IDs, facility names. And so I'm just going to say, go union them, right? And this is something that sets can intrinsically do. And if you want to see what all your choices are, again, just use that dot notation. And you can see we can do the difference. We can do intersections. We can find out if they're disjointed, if one's a subset of one another, if one's a superset of one another, and a union, and all these other things. In this case, we're just using a union, meaning we're just going to merge those lists together, however it turns out. And so now they are. Right, doing that, put them together, not in any specific order. Because again, sets don't really work in order. It doesn't really matter. That's not how they're meant to work. You asked it to put those lists together, and it did. Here's that combined to list. And again, if I print it out to the screen, you can see that. And it took those 2 lists and mashed them together. Likewise, we can find the differences, right? So we have all of our facility names, and then just our NICU names, and it's going to find the difference. What is the difference? So in this case, it's saying that we don't have those 3 in both lists. Print that out, easy. And then here's the last one, there's the intersection, meaning what do they have in common, right? So this was the opposite, saying what do they have different? This is saying what do they have in common? So again, facility names and NICU names. The only things they have in common are IMED and Dixie. And if we look up at our data, we have IMED and Dixie in the NICU, and we also have IMED and Dixie up here in the facility names. So yeah, those are the ones it has in common, right? So that's what sets are for. Sets are for doing these higher order things, these much, much more complicated things. These are things that if you were in another language like in Java or C# or C++, writing something to do this would take a heck of a long time. I've done it many times in those languages, writing logic to do like the exact same sort of things we're trying to do here, right? What do they have in common? What do they have different? And believe me, this is saving you a lot of logic and effort and coding, honestly. Okay. The other thing we have, right, so we talked about, where was it, right? Oh yeah, so we have other options, right? So we did the sets, then we have dictionaries and tuples. Okay, so dictionaries are the next item. So imagine just you have a dictionary printed, right? What does a dictionary mean, right? So you have a single word, and that word is never duplicated, right? So in the dictionary, if you're looking up the word student, there's only going to be one entry for student, right? You're never going to have two entries for the same word in a dictionary, right? So you can find student, and student might have lots of different definitions, but that's going to be off to the right. That's how a dictionary works in programming, meaning there's a single key that can never be duplicated, and then you have the value after it. What does it represent? So dictionaries are actually pretty nice. They help you do some things that make it a little bit more human readable. So I took the patient we had up above we've been using this whole time, right? We had a patient of Chad whose gender was male or whatever, age was 39. But with the dictionary, you give it a key, and that's this first thing, right? So you give it a string and then a colon, and so that's the key. And then whatever goes after that is the value, right? So we're saying the patient's key of name is Chad, the key of age is 39, the key of pregnant is false. This is what dictionaries look like. And again, these are the curly braces here. The difference is that we have the colon separating things. Okay. So I set one up. If we hover over it, it looks like this. Before, right, so, it's showing pregnant, age, or name as a string. Whereas before, if you remember looking up at these sets, it was just showing you a memory address, right? It was, oh, here's some random memory address. It doesn't matter, doesn't mean anything to us. Or on the lists, they were like, 0 through however number there was, right? 0 through 3 because that's the order that they were in, or the random memory address like the sets were, right? These weird things. Dictionaries are nicer because if you look at those, now we have actual like human readable sort of keys. This is kind of nice, right? We got pregnant, age, and name. Now we can sort of impart some meaning and order to these things, right? So again, that's what a dictionary looks like. So with the dictionary, before on our list, we were saying go grab the 0 item was the name, or the 1 spot on the index right here, right? So we're saying go grab the first thing, or I don't want to go back too far, but we were grabbing the gender and stuff, right, with those square brackets right here. So we were saying go grab the first thing or the second thing or the third thing. And we knew in our minds what that meant because we knew what the data looked like, right? So we were saying go grab all those things. But now with the dictionary, we don't have to be sort of obtuse like that. We could say just go grab the age, right? Because we gave it a key and it has the name and its age. So we're saying go grab this patient and go grab the age item. And if I do it, it's going to put it out 39, right? I'm printing out the patient's age. And that's a whole lot more readable, right, than the zeros or ones. Okay. And just to show you, gotta stop it, hang on. Okay, so we're not going to get a syntax error, but we're going to get a semantic error here. So if I try to treat a dictionary like a list, where'd we go? Right here. Right, so this is the exact same line here. So I copied 372 to 375. And here I'm referencing a dictionary how we're supposed to, right? We give it the key. But if I try to treat it like a list, just passing in the number, right? Because that should be right, because the 0 item is name, the 1 item should be age. And it says that you're not able to do that, right? So you have to give it a specific key. You got a key error. It's expecting the key name, not like an index number. So if you get that, just know that you're probably treating that data type incorrectly. Let's just jump down here to loops. So how do we loop over a dictionary? Okay, so we have a patient, and he's got 3 keys in this case. So I'm saying go loop over that patient, give me each key. And again, this is a completely random name. I just called it a K for key. You could have typed out the whole word key, or you could have called it something totally different. You could have called it attribute or whatever, it doesn't matter. So I'm saying go grab this dictionary, go loop through everything in that dictionary, and I'm going to print out all those things one at a time. So now you can see right down here, it's giving me name, age, and pregnant. Because this is what is different about dictionaries. They're a little bit more complicated to work with. When you loop over them, all it's ever going to give you are the keys. And the keys are not where the data are, right? The keys are just the attributes, the metadata, the key, honestly. But if you want to get the keys and the values, you have to invoke this method at the end of it, right? So we have a dictionary, the same one, called RESD. And then you just hit the dot item, like we've talked about before. You hit the dot, and this shows you, right? You can get the keys, just the keys, or just the values. Or if you hit items, you can get the keys and the values, which is what I'm doing here. Oops, get rid of that. Just one. Okay, so I'm going to say go to my dictionary and get all the items. And the items have keys and values. So now in my for loop, I have 2 items. We haven't seen that before. This is brand new. We're getting 2 variables that we can work with here. A K and a V, a key and a value. And then I'm just going to print them here. You could do whatever you want with them, right? Imagine you have all sorts of different logic in here. I'm just keeping it simple. Right, so now it's showing the key of name, the value is Chad, the key is age, the value is 39, key is pregnant, value is false. Okay. So those are dictionaries. In this case, I'm just working with one patient in a dictionary, but just showing you here, we can get more complicated, right? We can have lists of dictionaries or lists of lists or dictionaries of dictionaries. We can combine all of these collection data types together in whatever order we want. This is the one that makes sense for this example, right? So we have a list of dictionaries, right? So we have each patient as a dictionary, and we have a whole list of them, right? So we're dealing with 2 different data types now. And I just wanted to show you what that would look like so you can get a little bit more complicated. And this might come handy in some of the assignment work, which is why I'm showing it to you. All right, so we have a list, which are indexed 0, 1, 2, just like all lists are. They get numbered index, ordinals they're called. And then within that, we each have dictionaries. And remember, dictionaries don't have numbers. They have these string key values. You see? So now we can loop over them and get all that data that we need. So we're starting to get a lot more complicated data structures. And then I can just, again, loop through all of them. So I'm going to do that, all the keys for all the patients. So it should go, what is that? 3 times 3 is 12, or 9. So it should print out 9 things. And it did. So put all the keys for all the patients. Or we can be more specific, right? So the same data structure we're working here, the patient dictionary is the list of dictionaries. We're going to grab one patient at a time. And then instead of printing out all the keys and values, we just care about the gender, right? So we just grab the patient gender. And so this time it's just going to be male, female, female, male, female, female. And then the loop's over. Or if we want to avoid that loop, we just know which patient we want. Again, this is just showing you how we work with 2 different types inside each other, right? So a list and a dictionary. We're going to go grab the second patient, and we're going to go grab their name because it's a dictionary. And there we go. It says Annika Hodge. Okay, so that's how you work with dictionaries, or lists of dictionaries, I guess, in that last case. Sorry, I had to cough. Okay, so now we're on to tuples. This is the last collection type we're going to talk about today. A tuple is just like a list, except you cannot edit it. Once it's been set, it has to stay what it is. And to make a tuple, we're using parentheses like this. So that's the tuple, and this is the difference between a tuple and a list, right? So the parentheses versus the square brackets. Square brackets are lists, parentheses are tuples, and I'm just going to prove that to you, right? I created those, and I'm just showing you the type, right? It's telling us one's a tuple and one's a list. So with our list, we can edit it, right? So now that we've set it, right, we got this list. It's all these things. I can go edit it all I want. I can go append an item to it, which means, just add a number to the end of it. I can go remove an item, meaning it's going to go find this 984 out of that list and delete it. Or this is saying I go find the first item in that list and set it to 0, right? So it's going to change it from a 1 to a 0. So I did just 3 different things to it. And then I output the new list. And then likewise, if I try to do the same things to a tuple, exact same logic on a tuple, it goes red immediately, right? These are syntax errors. It says, whoa, tuple's not going to let you do these sort of things, right? You cannot append to it. You cannot remove from it. You cannot assign anything to it, which is what we're doing here. Okay, so tuples are uneditable once they've been set. So that's the difference. They're read-only. And then my wife was actually asking, why the heck would you want something that's read-only you can't edit? So think about it, I guess, in your mind for a second. There's got to be lots of examples, right? Constants, for example. Like if you have a list of constants and you don't want the program to be able to change those constants, or a programmer, I guess. Things like maybe there you have HR has a list of pay grades. Like if you're pay grade level 7 or pay grade level 8, those mean certain things. Or if you're doing scientific computing, right, pi is 3.14 or whatever, and you don't want people to be able to edit that. So there's lots of reasons why you might want uneditable things. Or like social security numbers for a patient, right? I don't know, all sorts of reasons. You don't want things getting changed. So tuples are the answer to that. And I told you before, there's a couple other types of things you can do besides dictionaries, sets, tuples, and lists. A couple of those other ones are stacks and queues. Those are way more specific and niche. Just know that those exist. I don't want to discuss them here. You probably will not need them for anything we do in this course. But they're worth knowing about if you're going to do any sort of actual programming. They have their places and their uses. They're way niche. They almost never get used in any programs I've ever seen in my 20 years of writing, but they exist and you can use them. I just don't want to talk about them here. Okay. So we're coming down here, getting closer to the end. So a lot of the reasons we use lists, it's sort of a blunt tool. It's kind of like a hammer. Is because we want to do just things, right? We have a whole list of data and we want to do stuff to that data. And a lot of the times it's just counting certain things in the data or finding certain things in the data, right? Like search through all this patient data until you find this, or read all the data and count all these specific things and tell me the number. Those sort of things are a little bit more base level things, right? We're not doing really custom logic there. We're just counting or finding. And so to do that, Python has some things that might help us avoid loops altogether. So I wanted to show you that Python has a couple of functions that if you use them, you might be able to avoid a loop altogether. And it's up to you. Loops are fine. Loops are great. You can still use loops. But if you want to get a little bit clever, you can avoid some loops in some cases. So take this example here. So I got a list of facilities. Again, it's the square brackets means list. And again, I work at Intermountain, so these are just some lists. I copied this up from, or copied it down from above, I should say. And what we want to do is we want to find out what spot IMED is at, right? So we have 0, 1, 2. We know, just by looking at the list, IMED is at number 2, right? Because it's the third thing in the list. But what if this list was, because the actual number of facilities that Intermountain has is over 8,000, because the way they categorize things, right? So like facilities, units, rooms, beds, everything. There's over 7,000 different things that you can have, and we don't know. We're not going to read all 7,000 ourselves. We want to find out what spot a certain thing is in this list. Well, Python's got you covered. Let me just start this program up. Skip past this because we've already done that. Here we go. Okay, so we got this sweet list of facilities. Okay, just like we saw, right? Okay, and so now we just want to, normally to do that, we'd have to do a loop, right? We'd say for facility in facility names, and then underneath that we'd say if the facility name is equal to IMED, do something. And then it would keep looping, right? It'd say McKD, nope. Primary Children's, nope. Then it's like IMED, yep. So we know, right? We're like, oh, third thing, we found IMED. So that's what you would do in a loop style. But here, Python has this new keyword called in. I shouldn't say in is new because we used it on our for loops, right? We used the keyword in on our for loops. What's different here is we're using it not on a for loop. We're using it with our if condition. So we're saying if IMED is in facility names, right? This is going to just return us a Boolean, right? We're saying if that is in there, then be true, otherwise you're false. So this is a quick way you can just search for content, right? Is IMED in that list? Yep, sure is. Otherwise, if not, it might have returned false. Another thing we can do, because all this is telling us, is that data in there, right? We're just saying, are you in there? Yes or no. But what we might want to do is what position is that in there, right? We want to know that that's number 2. We don't want to just know that the data's there. We want to know where exactly it is in that data. And there's lots of reasons you might want to know that. So here we go. Same thing. Are you in there? Yep. Okay, so we know you're in there. Now go tell us what spot you're in. So there's this other thing called index. This exists on lists and collections of things, right? You can do it on a tuple and a list. But you have this dot index, right? And again, you just hit the dot. Shows you all these things you got or you're able to do. One of them is index. And if you start the parentheses on it, it'll tell you what the index does. You give it a value. You can also give it a start and a stop location. Start and stop are optional. You can see how this is underlined and bolded value. That means that's a required parameter. You have to give it a value. But these are not bold or underlined. That means these are optional. You don't have to supply those unless you want to. And those are just saying, in the list, where do you want to look? Like, do you have a range of data you want to look? And if you don't pass those, it's just going to read all of the data. So by default, it's going to return or read all of the data. But it's looking for the specific value. Okay, so all it does is says, in this index method, you give it a value, and it's going to go ahead and look for the first time that it can find that. What's the first index where that value occurs? And then it's going to give you an error if it doesn't occur. Okay. So I've said, go look in my facility names list and go tell me what index spot IMED is in. And we'll print that out. And it came out to number 2, right? Number 2 is IDX, the index. And we know that, right? 0, 1, 2. So it found it, right? So we didn't have to do a loop for that either. So these are 2 little ways that we can bypass loops if you don't want to use loops. Although there's nothing wrong with using loops. Just be careful if you do want to do this approach. You saw how this index, when I did this, it said it's going to raise an error. It's going to throw an exception if it can't find that data. So if you're asking for data and that data doesn't exist, you're going to get a big exception and it's going to really hurt your whole program. So let's see what that looks like. I'm going to stop this and run it again. Put the breakpoint here. So now it's looking for Utah Valley Regional Medical Center, which is not in our list, right? So we're asking it to find data that doesn't exist. And this is the drawback from going this approach over, loops or whatever. So I'm saying, go tell me what index number Utah Valley is. And it's like, holy cow, I do not have Utah Valley. So it threw up this big exception, says pretty clearly, right? We don't have that in its it's saying we don't have that in this list. Sorry, I had to get a drink there. And then it throws this exception and stops your whole program. So there are some downsides to using that. Okay. I'm pretty proud of this little code. I was thinking of a specific example. I wanted to write something that's sort of complicated-ish. Not really. But this is putting together everything we learned on these last 2 modules with the if conditions and the loops and the ands and the equals and the not equals and all that stuff. So say we have a specific example of, we just want to get the basic demographic statistics, right? So let's say we're doing a study. We have, 10,000 patients. And we just want to get the breakdown, right? Out of those 10,000 patients, how many are male? How many are female? How many are other? And then give us, like proportions and stuff like that, right? Just do a basic, the demographic statistics, right? Just tell me what kind of population we're looking at. And so I wrote this code that should do that. Pause the video for a second, look at this code and see if you can figure out what it's doing. Hopefully you can if you take a few minutes to sort of process it in your mind, think about it. I'm going to pause for a second. You can look at it. I'll scroll down just a little bit so you can see more of it. There you go. That's all of it. Okay. So again, I was showing this to my wife the other day because she's a beginning Python programmer. And she had a pretty hard time with it, actually. And I was a little surprised. But the part she had a problem with was these lines. So I was curious if you guys got stuck on those lines also. But let's go through it. Let's walk through this. So I'm setting up 3 different variables. I'm setting a male variable. That's going to be an integer. I'm setting it to 0 to start off with. A female variable, also an integer. I'm going to set it to 0 and then an other. So I'm just setting 3 variables, starting them at 0, right? Starting it from scratch. Then I'm going to go loop through my dictionary, my lists of patient dictionaries, which we saw way up above. There's like 3 patients in there, I think. I'm going to grab one patient at a time. And now I'm going to go look at each of the keys for those patients, right? Key value. And I'm going to go say, for each patient I'm reading, right? I'm looping through all the patients and all the keys of all those patients. And I'm saying if I get to a key of gender and that key's value is male, then I'm just going to increment it. I'm going to take whatever value is in the male memory address. I'm going to take it and add 1 to it and assign it back to that memory address. So I'm just incrementing it by 1. Okay, so I'm just counting and I'm incrementing. I'm just tallying, right? I found another male, I'm going to add 1 to it. I found a female, I'm going to add 1 to it, add 1 to it, add 1 to it, and as long as I'm reading the data. So that's all we're doing. And then right here I'm showing there are, and I'm doing a little bit of math, adding all those numbers together, right? I'm saying there are these many patients, this many are male, this many are female, and this many are other. So let's run this. Let's see if it comes out just like you would imagine it to be. Let's get rid of that. Get rid of that. There we go. Okay. So again, we're looping through. Here's our first patient inside of the list of dictionaries. Here's our first dictionary item. We're getting all the keys and values out of it. And so now we're on name, right? So the key is name, so none of these are going to get hit. Moving on to the next key. This one's age, so none of these are going to get hit. Now we're finally to, no, now we're on the pregnant key. There we go. Now we're at gender. Okay, so now we have a chance of hitting it. So we have all these keys of gender. This one is male. Okay, so I'm going to add 1 to it, right? So my male is at 0, but now my male is going to be at 1 because I found 1 male, right? So if I hover over that 1 male, I still got zeros for all the others. Okay, so again, I'm going to keep doing that. Reading all the keys for all the patients. Oh, we found a female. That was a little quick, but I can see the female went up a couple. And now we're done with the loops. And now you can see the output right here, right? So it says we had 3 patients, 1 of which are male, 2 of which are female, and there's 0 other genders. Okay, so that's how this would look if you wanted to do some basic demographics. I mean, there's 100 different ways you could write this. This is how I chose to write it. You could write it 100 different ways. There's no wrong answer. But I did want to say that, again, talking about avoiding loops, right? Because we can avoid this whole loop right here by using the count method before. This is what the top thing we were talking about up here was earlier, right? With the counts and the ends and the indexes, there's ways to avoid loops. And so there's another method we have to avoid loops are counts. And so I'm saying go to my list of patients. For each patient I get, we're looking at the gender key, and then just count how many times we have males, count how many times we have female, count how many times we have other. So we avoided the nested loop, the second loop, the inner loop, by using this count. So 1 patient, 2 patient, 3 patients, and then it did it. So here we go. So it's saying, so again, I started all the numbers back at 0. So it said, yep, we had 1 male, 2 females, and 0 others using this count method. So we avoided a loop by using this count. Okay. hey, I'm going to skip over. Well, I don't know if I'm going to skip over it. Yeah. So another thing we can do, and again, these are all just in the hopes of avoiding loops, right? So we started off here with 2 loops, right? Outer loop for the patients and an inner loop or nested loop for the keys and values. Then I got rid of this inner loop by changing it to just these counting methods. So I just had the outer loop for patients. And this one is, we got rid of the inner loop. But now I can get rid of all the loops. And this is a little bit more complicated, and it's a little bit out of the scope of this class, which is why I'm not sure I'm not going to spend very much time on it. But there's something called lambda expressions. Lambda expressions are a lot more complicated, but it's instead of passing conditions like we were doing, like male or female or whatever, we're passing code to it. That's what lambdas are meant to do. And so there's this method called a filter, and a filter lets you pass some code to it. And this code I'm passing is a lambda piece of code. This is probably more complicated, so you don't have to do this. I'm just showing you have options. And the parameter I'm passing into my lambda code is an item. I'm saying every time I get an item, go look at the gender key, and if it's equal to female, we're going to do right here. We're going to set that to the male value. And it's going to go look in our dictionary of patients. So let me just show you what this output looks like. It's executing this 3 times. You can't see it, but I'm hitting F10 3 times to get through it because there's 3 patients in there. So now 1 male, 2 female, 0 other, right? So we reset them all to 0 just to make sure we were all on the same page. And then I ran this code, right? So 1, 2, and 0, just like all the other ones were. But this way we have 0 loops. So you can see in programming, there's, number 1, there's like 100 different ways to do anything. Number 2, it's going to be up to your style. If you like loops and you're comfortable with loops, great, go for it. If you want to get a little bit more fancy, you want to do some of those ends and counts and index things, great, you can do that. If you want to get even fancier, you can use these lambda expressions, and you can avoid some things altogether, and it makes your code a lot less verbose, meaning there's not as many lines of code, but it also makes it a little bit harder and less intuitive to read for other programmers, right? This is a little bit more complicated to understand what is happening here. But we get the same results as long as you know how to use these sort of tools at your fingertips. So I don't want to spend too much time on that, and I definitely won't be asking any questions on these things in the quizzes or assignments. I just let you know that these are things that exist to you, tools that you have at your availability. And so now we're almost done. We only got a few more lines of code to look at. We're going to end up with the other loop. We've only talked about for loops, but there is another loop type, and it's a while loop. So while loops are a little bit different, right? So for loops, we're going to just read all of the data, right? We know how many times we're going to do our loop in a for loop, right? Either because we know how much data we have, or we've gave it a range function and told it, run 5 times. So if we definitely know, or we have a definite number, that's what a for loop is for. A while loop is when we don't know how many times we need our loop to run, right? We don't know how many times we want our loop to run. That's what a while loop is for. While loops are a little bit more complicated to work with because you saw in the for loop, there's no conditions going on, right? It's just saying for this and that. Just read all of this data one at a time. While loop, we're sort of, it's a kind of a combination of a for loop and an if condition. We're saying, do looping as long as this condition is true. And as soon as that condition is not true, then the loop is going to stop. But in order for this condition to be true, we've got to do a few things, right? We've got to have a condition that we can check. And each time we do our loop, we need to have a way to alter that condition to change it so that this loop will have a way to stop, right? So we're saying, this is a simple example, right? Just say we want to loop 10 times or 11 in this, 10 times, 10 times. So we were saying as long as I is less than 10, right? So we have a variable called I. We've set it to 0. This is a control variable in this case because this is controlling the execution of our loop. We give it a special name. It's called a control variable. Okay. And so we're saying as long as I is less than 10, we're going to keep looping. So we're starting at 0. Is I less than 10? Yes, it is. We're going to print it out. I'm casting it to a string so I can print it out. And then in there, I got to do something to modify this control variable. I'm saying, all right, we did a loop, so I'm just going to add 1 to it. So I have a way that my loop's going to end at some point. So just like you'd imagine, 0. Now I'm going to change my I. It's at 0 right now. I'm going to add 1 to it. So now my I is 1. So now it's saying, is 1 less than 10? Yep, sure is. Add 1 to it. Is 2 less than 10? Is 3 less than 10? You can see right here it's putting out all the numbers, doing all the checks. And now we're getting up here. Here should be the last one because we're at 9. Is 9 less than 10? Yes. We're going to loop. We're going to add 1 to it. Now our I value is 10. Is 10 less than 10? No, it's not. So my loop ended. Okay, so that's a while loop. It's just like a for loop, except we have conditions that we're asking for that have to be met each time. And we have to do something that will alter that condition so that our loop will end at some point. So you might be wondering, why would you ever want to do such a thing? And so I'm trying to take a similar example of what we did above. Remember when we did the for loops and we introduced the break condition? We introduced that break condition when we had a lab value of 250 because we didn't want to read the other 9,700 things. So by using that break condition, we avoided all of that reading. We can do something similar in while loops. That's kind of what while loops are kind of honed and meant to do, is to answer some of these nebulous things that you don't know how often it's going to happen, right? Even though you have 12 million patients, you don't know how many times you need to loop through to get certain conditions met. So here's a scenario, right? So we have all these patients. I have some new patients here. We have 6 now instead of the 3 that we've been doing. And I have different gender statuses. We had male and female, but now I have a T for transgender. And so now let's say our scenario is we as a clinic want to just go loop through. We just want to know, do we have at least 2 transgender patients in our population or that we've seen in our clinic? So to do that, we don't know how many times we're going to loop, right? We could loop through all the patients. That's fine. But if we want to do something specific, we just want to know, are there at least 2? That's a whole different story, right? We just need to read until we've hit our condition, and then we can just stop. And it saves us a lot of execution. So pause here for a second, pause the video, look at this code, lines 524 through 533. And in your mind, see if you can figure out what's going to happen. It's really important that as fledgling programmers, you're really trying to think through these things and not just sort of taking them for granted. Okay. So now we have, we're starting a new variable called transgender patient count. We're setting that to 0. And we're creating an empty list of trans patients. Okay, so these are our variables we're starting with. Now we're in a while loop this time. So we're gonna loop. We're gonna do all this stuff just so long until we have more than 2 patients, 2 or more patients, I should say, right? So we're gonna keep doing this until our criteria is met. And we're starting at 0. So nothing's been met yet, right? 0 is less than 2, yep. Okay, so to do this, now we're going to a nested loop, another loop. So now we have all these patients. This is coming from this data right here, right? It's a list of dictionaries. So we're going to go loop through all those patients. We're going to grab the first one, which happens to be me. We're going to go look at the gender key of that patient and see is it equal to T for trans. And it's not. Okay, we're going to go on to the next patient. Who's this one? This one's Annika. We're going to say, is she a trans? Nope. Next patient. This is Jill. Is she a transgender? The answer is yes. Okay, so now we found a patient who's transgender. So now we got to increment our control variable, just like we did on our simple one up here, right? We have to do something with our control variable so that our conditions will be altered a little bit. So in this case, we're just going to take the transgender patient count and we're going to add 1 to it. And let's say we also wanted to print out a report of who these specific patients were. So I'm just going to grab that patient and throw it into a list up here. So our trans patients list shows Jill in it, and our count is 1. Okay, and so we went to the while loop, and it said, is 1 less than 2? It is, so we're going to keep running. So we went through the patients, Is this one transgender? Yep. Now is 1 less than 2? No, it's not. So we found our 2 patients and we stopped executing. Okay, so we found them, right? So we have Jill, and then we have Colton. So if we look up at our data, who were the T's? We had Jill and Colton, right? So we found the 2 that were transgender. And we didn't know that, right? We didn't know, even if we had 2 patients that were transgender, we didn't know how much reading of the data we would have to do. We just knew what we were looking for. And once we met that criteria, then the while loop exited. And you can do this all exact same stuff using a for loop, right? You could have had this all in a for loop, and once your number hit 2, you just could have hit the break keyword, right? So it's not like a while loop is doing something that a for loop can't do. I'm just showing you that you can think about it differently and write it differently with the while loop than you can in a for loop. So it honestly just comes down to personal preference, whatever your brain is easier to think with. The while loops can't read data the same way a for loops can, so they're a little bit limited in some respects and better in others. But using a while loop, we do have a special problem that we can only get in a while loop. This is something that a for loop isn't going to do for us, technically. Okay. So looking at our code here, what is going to be, so again, think about through this here, line 541, 42, and 43. Just look at those 3 lines of code. And think about this. How is it going to execute? What's going to happen? And are there any issues with this code? Okay. Hopefully you paused the video and took a second to think about it. So the issue here is we have our control variable I. We set it to 0, just like we did on all of our other while loops, right? We have a control variable. We set it to a number. We have a condition we're checking for. That's all true. And then we're doing something in that loop. You can see it's printing out 0, 0, 0, 0. So the issue here is we're never doing anything with our control variable. We don't do anything to alter the conditions of I. So it's always going to run, and it's never going to stop, right? So I'm going to put a breakpoint here. I'm going to continue running my program, and you're going to see, oops, right here, get rid of that. This program is never going to stop. It's just outputting zeros millions of times. 0, 0, 0, 0, 0, 0. It's never hitting my next block of code, right? So that's what's called an infinite loop. That loop is something that's never going to end, okay? And that's something you don't want. Infinite loops are going to destroy your program. They're never going to finish until either your program times out or it eats up all the memory in your system and shuts the whole system down. So you got to be very careful using while loops because you can get into situations where you have infinite loops like this with a while loop. And the whole issue here is we didn't modify our control variable to have a condition where it would stop, right? So we're saying keep going as long as it's less than 10, but we never do anything with the I so that it can have a chance to stop, like we do here, right? We have our control variable and we're adding 1 to it, so it has a chance to stop, right, when our conditions get met. And finally, this is the last one, another while loop. So look at this one and see if you can figure out what the difference is here. It might be obvious to you. On lines 546 through 549, I'll give you a second to look at it. Okay, and so then what's the issue here? Let's just run it. I got to get rid of this because this will never stop. Okay, so let's get down here to line 546. Nope, there we go. Okay, so this one might look similar, right? Because it's just like the one we started with, right? It's almost identical to that. The difference is we have a logic issue, semantic issue, right? So we have set our control variable, I, we set it to 0. We're doing a check. Is it less than 10? Sure is, right? 0 is less than 10. Print it out, and we're going to modify our control variable, so that's good. But if you look at I, we're going the wrong way, right? We did minus instead of plus. So this is a logic issue, semantic logic, semantic error. So now it's going to get smaller and smaller, and it's still never going to get up here towards the 10 to stop. So we had a variable, we did something to modify it, we just did the wrong thing. So I'm just going to let this run to show you. I'm not going to stop it, but you can see down here in the output, it's looping, and the numbers keep getting smaller and smaller. So it's already gone through that loop 10,000 times, and it's never going to stop. until you run out of memory or some process kills it or it times out or whatever. So we've sort of broken our system, right? We've already done 25,000 loops. Okay, so those are infinite loops. Okay, so that's pretty high level intro to loops. That's all I had for that. So work with them. The assignment has you working with them also quite a bit. But make sure you master these. These are very common. These are the base sort of building blocks we have for all of our programs. Not just loops, but the Boolean conditions that we did on the prior video. Just make sure you've really got a firm grasp on them, because everything we do from this point forward in the class is going to rely on that and going to assume that you have a firm grasp on it. Okay, thanks.